in the room and online. So this is the second in a series of 3 sustainability training sessions that we're looking to run. So it's kind of a joint effort between the BGA Early Careers Group, the British Tunnelling Society Young Members Group, and the Early Careers Group of the Engineering Group of the Geological Society. So then the agenda for today. So basically from 5:30, there's been a bit of networking. I don't know if I can't see Pizza's arrived yet in the room.
On the way.
It's on the way. Yeah, that's good. And then basically I'm going to give a 20-minute presentation on sustainability in geotechnical design. And then we're going to look at sustainability and construction with Joseph Gallagher giving a presentation. And then after that, we've got an activity as well. So that activity is kind of going off of what we did in the first session. It's basically just a kind of fictional project where we're trying to get a bit more interaction between people online and in the room, and just coming up with kind of ideas for new for more sustainable design options, basically. So that's to look forward to. And then hopefully, yeah, they'll wrap up about 7:30. And then I don't know if there's any further drinks and networking planned for those in the room, but yeah, then we can go and have some dinner for me. So, as a bit of a recap then, so in the first session, we kind of had a presentation on some of the kind of fundamental aspects of sustainability. And so we kind of looked at the UN Sustainable Development Goals and kind of considered how it's more of a, we can't get tunnel visioned with sustainability focusing just on carbon, and for things to be truly sustainable, we need to cover all aspects, covering from like environmental, social, economic, and health aspects of sustainability. We also looked at carbon accounting and like all the different carbon accounting modules. So looking at like the A1 to A3 product stage, so the carbon factors associated with the materials we use, and then looking at A4, the transport of those materials to site, and then the A5 being the construction processes and waste on site, the carbon emissions produced, and then B stage, U stage emissions, so the operational energy, any repair, maintenance, refurbishment of the asset, and then finally end of life as well. So the emissions associated with demolishing or dismantling the asset and then transporting that waste to wherever it needs to go, be it landfill, recycling, etc., processing of it, and then finally the disposal of it. And then we kind of looked again like how we can be more sustainable generally. And so we kind of looked at the carbon and waste hierarchies. And so it's kind of summarized in this image here, whereby first of all, we just try and use less stuff, build nothing ideally. And then we reuse some of it if we can't use less or do nothing. And then specify basically low carbon alternatives. And so you can kind of also see the start with reusing, go down to upcycling, go down to recycling, and then downcycling, and then finally disposal, as these are kind of the order of preferences for how we want to approach our work in terms of sustainability. And then we also looked at BNG as well. And so obviously it's a fairly new legislation in the UK that requires 10% biodiversity net gain, and we looked at how there's kind of measurements and metrics for this and how it can be measured based on connectivity of habitat, the condition of habitat, and the distinctiveness of the habitat as well. And so these all contribute to the score of the land. And so obviously, again, there's a similar hierarchy around we want to leave as much of it in place or and avoid it if possible, or if we can't avoid it, use less of it, build on less of the land, and then it's basically restore it to how it was before the construction and before the development. And then finally, the kind of worst case option is to compensate off-site with biodiversity elsewhere. So yeah, so we kind of looked at all these different fundamental parts of sustainability. And then finally, we kind of touched upon regenerative design and how it's kind of a bit of a new concept, and it's kind of going beyond sustainability and actually trying to have a net positive rather than just a net zero result on the environment. We're trying to have a positive impact on the environment, and so BNG is a good example of this. We're having a net gain, and it looks at systems thinking, and how what we do feeds into these wider human and natural systems and how we impact them. So that's kind of a quick recap of what we covered in the first session. And so I'm going to go through a few more aspects. But first of all, there's a few slides I've stolen actually from various Ramble ones, which I think are quite interesting for us to consider our impact. So we touched on just with the regenerative design. And so this is a good, I'm sure Negin and Ramble colleagues will kind of be aware of this. So you can kind of see this image, and so you can see this is like what we see typically. So you can see there's a green wall, you can see there's some flowering plants, there's a route in the middle with active travel, etc., and it all looks good. It's all layered vegetation. And then all of this actually contributes to all these different things as well. So there's carbon storage, there's nutrient cycles, there's air quality regulation, microclimate control, noise reduction, recreation, health, biodiversity, air purification, pollution. All of these things are kind of being impacted. These are like parts of the wider systems that are impacted by the wider built environment. And I think in this particular example as well, you can kind of see some of the geotechnical aspects as well. So we've kind of got the retaining wall there, we've got the green wall, we've got the slopes and then the embankments and the soil. So you can kind of see, I think, we might not think immediately that geotechnics has a major sustainability impact, but I think you can kind of see here how it does touch on it. And then just to extend that a bit more is here's like another kind of little case study. I don't know how clear it is on the screen, but you can kind of see again all the different impacts and sustainable design features that have been done. So with this bridge, you've got the embankments and you've got the wildflowers on the embankments for better insect life. You've got fauna passages between the two sides of the embankment and the road to allow connectivity. You've got layered vegetation on the embankment, and then artificial reefs around the foundations, use of low CO2 concrete and zero carbon steel rebar. And so you can kind of, I won't go through all of them here, and we can send out the slides afterwards, but you can again see some more examples of how the geotechnics and ground engineering in particular can play a role, and the different aspects of sustainability that are impacted, which we might not consider initially. And then another kind of tunneling example as well here. So just you can see on the screen there's all sorts going on: rainwater harvesting, look at all the construction materials, sustainable plant fuel, low carbon steel and concrete, precast, electric site vehicles. I'm sure we'll come on to some of these later on. Yeah, feed low cost, low carbon energy back into the local community, local waste, sourcing local workforce and materials. So yeah, lots of stuff going on, and again, a lot of it with geotechnical aspects to it. Yeah, you can see replant backfill to create new habitats, maintenance of animal habitats. There's all sorts going on that we can consider within our work. And so one of the things that we kind of, again, going back to the hierarchies, and the first one is avoid, and so build nothing. And so one of the things that we can do in ground engineering is using enhanced monitoring. And so, for example, if there's been a slope failure, we can monitor it and we can see, I mean, maybe that slope's now reached an equilibrium and it doesn't actually need much more intervention. We can avoid any additional works required on it. Or we can kind of monitor it throughout the asset's design life. So before a failure happens, we can intervene earlier and avoid any major interventions and help maintain the assets as well. And then we've got things like the observational method, whereby as we're constructing it, we can see what impact it has. So obviously when we're designing, there's lots of safety factors applied. We can actually observe if, say, the retaining wall is deforming more than we expect it to, and then we can have like obviously prepared measures in place, but perhaps they're not needed and we don't actually need to use them. So again, a way of avoiding unnecessary kind of over design and excess materials. And then we can also just challenge the brief. And so sometimes we can like start at the very project concept. And so like, is the way that the design's being proposed, is it actually like solving the core problem? Is there a better way of solving it? If there's too much traffic, can we propose like, oh, perhaps using public transport rather than just adding an additional lane to the highway, that kind of thing. Or we can then optimize the scheme. If we do need a new road or a new asset, can we change location? Perhaps they haven't considered all the geology at that particular site. If there's soft ground or something, can we change it to where there's better geology? And then also look at what's called sweating the asset. And so that's just basically eking as much design life as possible out of it, and trying to maintain it as much as possible. And so, yeah, avoid having to replace it at the end of its design life. We can look at how it's performing and just get as much use out of it as possible. So there's all these ways of avoiding it. And so then if we move on to switching, the next stage in the carbon hierarchy. So this is kind of basically summarized. Oh, yeah. Now as we all get jealous online. But so yeah, so with value engineering, it's something that we tend to do as standard anyway in our day-to-day jobs. Like it's kind of part of our jobs as engineers, and it's often not really considered as sustainability, but it's kind of inherently sustainable if we can optimize the design, and that results in using less concrete, using less steel. That also means less embodied carbon, and also like things like less embodied ecological impacts. And so that's why, and you see these effects kind of cascading throughout. And so if we kind of think back to that carbon accounting and all the different modules like A1 to A5B, if we use less materials, it reduces the A1 to A3. It also means we have to transport less materials, so there's less transport emissions. It means we have to spend less time constructing it on site, so there's less waste of materials, there's less emissions from all the plant and construction processes on site. It also means there's less materials involved in the refurbishment and the repair of it, and then there's also less emissions associated with the demolishing, deconstructing, transporting the waste, and then processing that waste on landfill, etc. So you can kind of see how using less materials cascades throughout the life cycle of the asset. And that also ties into things like DFMA, so designing for manufacture and assembly. And so if we can kind of modularize a lot of the components, and we can use precast concrete components that are built off-site and brought to site, it means there's going to be less wasted material. It makes the whole design process more efficient, use less waste material. So again, it's making the design more efficient, but it's also having the impact of making it more sustainable. Reusing materials. So again, we're looking at the hierarchy there. And so obviously the carbon's kind of already been invested in those materials. And so if we can reuse them, then we're avoiding the A1 to A3 emissions. We don't have to transport them to site. They're already on site. If we're reusing foundations, they're already in the ground, etc. So again, it's basically fundamentally using less materials. And so there's less embodied carbon. And then GI data. So in the first session, we had a presentation from GEL, the GI contractors, and they highlighted how important ground investigations are. And so they're measuring the carbon of their operations, but often it's important, it's not to consider it as a false economy. And so it might appear like, oh, if we did one less borehole, we're saving carbon emissions from the GI. Then of course, we don't have the data from that borehole, and so that results in more conservative design assumptions, and more conservative designs, more materials, more concrete that's going to be required. And so yeah, getting as much GI data as possible so that we can optimize the design as much as possible. And then the next one, so basically kind of replacing, oh, I should have said actually, sorry. So the image on this is like these, it's a company called GeoGrow, but there's several different companies doing the same sort of thing where it's kind of they have these bags and then they can basically build them up to form a retaining wall and then they can be planted. So again, avoiding the use of concrete and steel, but then there's also benefiting biodiversity and all those other system benefits as well that we saw in some of the previous slides. And then yeah, innovate, lead, slash is kind of, this comes more to the replace side. And so it's where can we basically use alternative products? So things like low carbon materials, low carbon concrete, recycled steel. Can we use these new kind of innovative products instead of the traditional business as usual case? So on the screen, there's the example of the hyperpile system, which people might be familiar with. So it's Keltbury have designed this pile, which is kind of hollow. And so you're avoiding all of that concrete in the center of the pile. So it's using less materials. It can also be pulled back out again. So again, it can be reused after it's served its purpose. Perhaps the building's changed or the asset's changed, it's no longer required. It can be reused. It can also be used for like heating as well, as they can put kind of like kind of ground source heat pumps effectively down the poles as well. So again, saving operational energy. So it's these kind of innovative products that we can try and explore and use in the work that we do. And there's lots of them out there now as well. And so I kind of encourage people to look online and go to kind of industry events and showcases. And there's lots of stuff out there. And so yeah, so that's basically, it comes down to just replacing what we're already using just with better versions. And then finally, I've got kind of inspire at the end. So that's, I've kind of gone through different ways that we can improve the work that we do on our projects, but then I think it's a bit more of a, I guess, not quite as a hard saving, but as a soft saving and more sustainable. We can inspire colleagues and people around us, so we can educate ourselves and educate colleagues, so we can investigate new solutions, we can support new solutions. So for example, there's a startup called Low Carbon Materials, which have used can actually produce carbon negative concrete and asphalt, but they create aggregate that sequesters carbon from the atmosphere. And so we can champion these kind of new products. We can push for them to be used on projects that we work on. We can spread the word of these new products to colleagues on project meetings. We can like kind of speak up and say, oh, I've recently learned about this one company that's doing this, or there's this new project. We can kind of just basically bring it up and offer it as a solution, and kind of challenge business as usual. I think there's a lot in the industry of people doing things just because it's always been done, and so you kind of get some of the more experienced members of teams of companies doing it. They pass on how they've done it. They don't. It's worked for them for the 20, 30 years. They keep doing it that way and then pass on how they're doing it to younger generations. And it's up to us to kind of break the mold a bit and challenge what we've always done, because what we've always done is creating problems. And then yeah, we might not have the power on decisions, or the power to make decisions on projects. Whether we're designers or contractors or clients, we can always kind of pass the buck and say, if we're designers, like, oh, it's the client's fault, they're not going to give us enough money for it. Or if we're contractors, we can say, oh, it's the designer's fault, they didn't tell us to do it this way. Or with the client, we can say, oh, the designers and contractors didn't tell us we could do it this way. And so we can always pass the buck. But so I think it's always important that we at least ask the question. We can raise it up in meetings and say, like, kind of, oh, why aren't we doing it this way? Why aren't we reusing these foundations? Why are we demolishing this bridge when we could retain it and improve it and refurbish it? And then we can, in our reports and stuff and in the work we do, we can just provide alternative solutions. We can provide the options, we can explain the impact, we can do the carbon accounting and say, like, this is the traditional way, this is how much it kind of costs, this is the carbon impact of it, or you can do it this way, and this is the reduced carbon, this is the carbon savings, this is kind of, we can explain how this is the equivalent to like the whole carbon footprint of your whole company if you just do this one saving kind of thing. So yeah, and then obviously a little image of Greta on time as a symbol of inspiring people to make the change and be different. So yeah, so just about on time, but that's the end of my presentation. So I don't know if Petros in the room, I can stop sharing and you can start sharing. I think you guys are on mute as well in the room.
Hello guys, can you hear me?
Yeah, I can hear you now.
Maybe if we mute the screen now.
Was here now?
Hello now? Hello now? Hello now?
Should be a match.
I think you get yourself in that.
Yeah, it's better now.
So now, okay. Yeah, so hello again. Hi everyone. You can hear me. Okay, perfect. By the way, great presentation, Mikey. You know, a lot of really nice information. I hadn't seen Greta for a while. That was quite good, but generally a lot of great information being shared. And I just want to start this by saying thank you to the hosts. Yeah,
Welcome.
yeah, I think it's a great. I really like what you guys doing. I think it's very important, very interesting, and obviously thank you to Babikir for inviting me to be a part of this. Yes, and yes, let's go through the presentation I put through for this meeting. Now, I just want to clear out that you know. Again, we have people with a lot of experience and a lot of knowledge within sustainability and all this kind of stuff. So take it easy on me, guys. Okay. But yeah, let's start. So it's the oh yeah, by the way, because it's the British Tunneling Society involved with this and the geotechnical, I thought it would be a great. It would be really interesting to maybe talk about tunneling, as you probably all know, as ZG, we are tunneling experts. Yeah. And yes, that's what we're going to cover today. We're going to cover sustainability in tunneling design and construction. So the first slide, yeah. The first slide is we're going to touch a little bit on the historical context of how tunneling was done back in the day. So, tunneling was saved civilization for a very long time, enabling transportation, water management, and urban expansion. While early methods drove progress, they were resource intensive, high emissions, and environmentally destructive. Ancient civilizations like the Romans, Egyptians, and Mesopotamians relied on manual excavation and timber supports, often leading to deforestation and material waste. There is a very nice example of the Cloaca Maxima in Rome. I don't know if you guys have been in Rome. It's a beautiful place. You have been, yeah, perfect. So obviously this tunnel remains one of the earliest drainage tunnels still in operation. You can see it on the left bottom picture. It's a marvel of engineering. Yeah, still standing. The Industrial Revolution brought mechanized seals and reinforced concrete, improving efficiency by drastically increasing energy consumption and emissions. The London Underground is a good example. Through groundbreaking, relied on cut and cover excavation, a process that destroyed large surface areas and disrupted communities. On the 20th century, speed overtook sustainability. Dynamite blasting, compressed air tunneling, and excessive concrete and steel use led to high emissions, ground instability, and significant health risks for workers. These methods, while effective, left a lasting environmental impact. So this history is part of our industry's legacy, of course. While past methods were not always sustainable, they paved our way for modern tunneling expertise. Yeah, and we in Joseph Gallagher, we recognize this, of course. Moving on to the next slide, we are gonna touch a little bit on defining sustainability. I know, Michael, you've covered that in 2 sessions now, but I just have a slide. I'm gonna be we're gonna go through it fast. So sustainability in construction ensures infrastructure development meets present needs without compromising future generations' ability to thrive. It balances environmental protection, economic viability, and social responsibility. So you can see on the top left corner, we have the United Nations Sustainable Development Goals. It's 17 of them. And some of them have a direct impact on the tunneling industry. Specifically, number 9, which is industry and innovation and infrastructure, encourages the development of resilient, sustainable, and inclusive infrastructure with reduced carbon footprints. We got 11, sustainable citizen communities, 12, responsible consumption and production, and 13, climate action. Now, tunneling aligns with these global sustainability goals by reducing surface disruption, moving transport efficiency, and integrating low carbon materials. Let's move on to the next slide. What is sustainability in construction design? Very briefly, again, sustainable design goes beyond reducing emissions. It's about creating resilient, efficient, and long-lasting infrastructure while minimizing environmental, economic, and social impacts. A well-designed sustainable structure optimizes material efficiency, energy use, and waste reduction to extend its lifespan and lower operational costs. Material efficiency is a key principle of sustainable design. Green Building Council's low carbon concrete roadmap provides a framework for reducing cement-based emissions through alternative binders like the GGBS. I'm not going to try to pronounce that. Fly ash and geopolymer concrete. Similarly, the UK Waste and Resources Strategy mandates that at least 70% of non-hazardous construction waste must be recycled or reused. Life cycle performance is also essential. The Construction Playbook 2022 mandates whole life costing in government funded projects, ensuring that sustainability is not just an upfront consideration, but integrated into operation, maintenance, and decommissioning. Why sustainability in tunneling design is essential. Tunneling offers a sustainable alternative to surface infrastructure, reducing environmental disruption and optimizing land use. However, it is energy and material intensive, requiring large amounts of excavation, concrete, and steel. To make tunnels more sustainable, efficient design and material choices are essential. By using fiber-reinforced concrete, recycled aggregates, low carbon steel, we can significantly cut embodied carbon. Advanced soil structure modeling helps with refining tunnel designs, optimizing materials, and reducing excess reinforcement. Energy efficiency is another key factor when it comes to tunneling. Smart ventilation, LED lighting, and renewable energy integration help lower emissions over a tunnel's lifespan. UK policies like the Transportation Decarbonation Plan and PAS 2080 emphasize the electrification of tunnel equipment to further improve sustainability. Regulations such as the Net Zero 2050 and ISO 14001 ensure that whole life carbon assessments guide every stage of tunnel design from construction to operation. With these strategies, tunnel becomes more efficient, durable, and environmentally friendly and responsible. Now, this is a very important slide for me. I call it the right first time, reducing waste and improving efficiency. The reason of that is because I am the group quality manager for Joseph Gallagher. In quality, it's very important to doing things right at the first time, but it doesn't only stick to quality, it expands to every aspect of the works. It covers health and safety, the reworks, it covers sustainability, I would say, maybe even more than quality. I know they're all related, but let's get into this slide. Getting right the first time is one of the most effective sustainability strategies in tunneling, and I would say in every activity that we undertake. Yeah? Every mistake leads to wasted materials, higher emissions, and unnecessary costs. Precise design and execution reduce rework, optimizes resources, and lower the environmental footprint. Joseph Gallagher's group, Prevention Not Correction, as you can see on the bottom left, this is our Joseph Gallagher initiative, reinforces this commitment by focusing on early stage accuracy to eliminate rework. A data-driven approach ensures accurate alignment, geotechnical stability, and efficient material use, while BIM and digital twins allow for early problem detection, preventing costly mid-project adjustments. Precision in material planning and quality control minimizes waste, ensuring that reinforcement concrete and excavation will match exact project needs. Rework can increase carbon emission by up to 50% per project phase, making early stage accuracy crucial. Energy efficiency is also impacted. Unplanned re-excavation, additional TBM operation, and machinery idling drive up fuel consumption and extend project timelines. By implementing prevention, not correction, and getting things right done the first time. Obviously, here at JGL, we ensure sustainable, cost-effective, and resource-efficient approach to tunneling. But again, this, as you see on the top left corner, I want to take a moment here. For anyone that's not aware, this is the Get It Right initiative. We as JCL, we are a member of the Get It Right initiative. If you guys haven't heard of it, I would really suggest to go have a look. They have some amazing information on the platform that you can get a lot of ideas. And because I know there is a lot of designers in this room and probably in the call, they have a lot of guides on how you can get it right the first time within the design as well. Yeah. So very interesting. Definitely have a look. Moving on, we have economic and social sustainability in tunneling. Big part. Yeah, sustainable tunneling isn't just about protecting the environment. It makes financial sense, drives jobs creation, and improves the communities we build in. By embracing sustainability, we're making projects more cost-effective, future-proof, and beneficial for everybody. For starters, sustainability saves money. Using energy-efficient equipment and sustainable materials reduces waste and lowers long-term operational costs. Take the HS2 as an example. Probably a lot of you have worked on HS2 projects. Yeah. By using low carbon concrete and energy efficient TBMs, they're expecting to cut lifetime operational costs by 40%. This is not just a small saving, it's a game changer for how we approach infrastructure projects. At the same time, we're creating jobs and developing new skills as tunneling shifts toward low carbon designs, digital modeling, and electrification. We need a workforce that's trained for the future. That's why apprenticeships and training programs in sustainable construction are becoming more important than ever, like this one, yeah? Because the industry isn't just changing how we build, it's changing who builds it. Let's not forget the impact of local communities. Sustainable tunneling helps cut congestion, improve air quality, reduce emissions. Great example is the Northern Line extension, again, which not only improved transport links, but also minimize disruption for people living nearby. That's the kind of future we need to aim for, where infrastructure works for the environment, for the economy, and for the people. Sustainability isn't just a nice to have, it's the smartest way forward. Yeah, I like to quote that. So now moving on to UK carbon management and tunnel design. Again, we're going to make a reference to PAS 280, the whole life carbon approach. When we talk about sustainability in tunnel design, it's not just about reducing emissions during construction, it's about managing carbon at every stage of the tunnel's life cycle. In the UK, we follow the PAS 280, a framework that ensures carbon reduction is built into design processes right from the start. Instead of focusing on upfront emission, PAS 280 pushes us to think long term. One way we do this is by using low carbon materials. Again, these materials help cut embedded carbon without compromising on strength and durability. The construction method also plays a key role by electrifying TBMs and optimizing logistics. We can reduce emissions from excavation transport. But it's not just about what we're building, it's about how we build it. Smart tunnel alignments help minimize excavations, etc., etc. Sustainability effort doesn't stop on the tunnels. Smart operation is built, through smart operational strategies like energy efficient lighting, dynamic ventilation, and energy recovery systems will ensure that tunnels remain low carbon throughout the lifespan. Let's move on to the next slide. Sustainable materials. That's a big topic. We can talk about this for a lot of hours. But let's go through the slide. Material selection plays a defining role in sustainability of tunneling. Traditional materials as Portland cement and virgin steel contribute to high levels of reported carbon, making alternative materials a necessity for sustainable construction. Again, references to the GBS, fly ash, polymer concrete. They can cut emissions down to 40%, which is huge. Fiber reinforced concrete further reduces steel reinforcement needs, decreasing overall material consumption while enhancing structural integrity. And I'll be very honest, I see more and more fiber reinforced concrete being used on sites, which is very impressive. And this is definitely something that is driven by sustainability factors.
Game changing, really, this fiber industry nowadays.
Yeah, we use it. I see it more and more, which is very impressive. Yeah. Recycled aggregates help close the resource loop by repurposing excavation, spoil, and demolition materials, ensuring that new tunnels are built with minimal reliance on virgin resources. Yeah, the BS 85,000 standards regulates the use of secondary cementitious materials, ensuring that sustainability does not come at the expense of performance or durability. Procurement. Another big topic within every organization, how we take into account sustainability within procurement. Another big question. Sustainability in tunneling starts with responsible procurement and supply chain management. Choosing low carbon materials, ethically sourced components, and local suppliers reduces environmental impact, emissions, and waste while supporting regional economies. Ethical and sustainable material sourcing ensures that concrete, steel, and tunnel linings comply with the relevant standards and laws and legislations and policies that promote carbon supply chains and whole life carbon consideration. Local supply chain integration plays a key role in sustainability by sourcing materials regionally. Transport emissions are reduced and economic benefits remain within local communities. The HS2 material efficiency strategy is a prime example of how responsible procurement can significantly lower a project's carbon footprint. Circular economy. Tunneling generates large volumes of excavation spoil, which is traditionally treated as waste. You can see the picture on the right lower corner. Yeah, it's very interesting. I didn't keep the there's not really anything explaining what this graph is about, but I'm going to give you a nice little brief. So it's different industries and the waste in tonnage. So on the left-hand side is the x-axis, barbecue. Yeah, so the x-axis we got the tonnage, and on the y-axis we have years. So you got 2000, and it goes all the way to, let's say, 2020. So different industries, you can see that on the yellow one, the biggest one, yeah, the yellow one is the construction industry. So we as construction, yeah, we create a lot of waste. Back to the tunneling though, a circular economy approach, we ensure that materials are recovered and repurposed, reducing reliance on virgin materials while minimizing environmental impact. Spoil reuse is a key circular economy principle. Excavated materials can be repurposed for backfill, embankments, or aggregates, eliminating landfill disposal. The UK Resources and Waste Strategy mandates waste reduction and material recovery, requiring projects to develop reuse strategies before construction begins. Other circular economy principles include the prefabrication of tunnel segments, which minimizes waste and improves quality control, and designing for disassembly, ensuring that tunnel components can be recovered and repurposed at the end of their service life. Energy efficiency. Tunneling is energy intensive, high demand for excavation, ventilation, lighting, material transport. One of the biggest changes we've seen is electrification. It's a big step moving away from diesel powered TBMs and support equipment to electric alternatives significantly lowers emissions. Ventilation is another major energy consumer, but energy recovery systems can make a huge difference. By capturing waste heat from ventilation exhaust and even using regenerative braking from tunnel transportation vehicles, we can reduce the need for additional power, making operation far more efficient. Renewable energy is also becoming a key part. Solar panels, wind power, all this beautiful stuff. Finally, smart energy planning is crucial. Smart grid technology and demand optimization helps schedule high energy tasks during off-peak hours, reducing strain and lowering costs. Now, what I want to discuss about before we go on the next slide is this is obviously at Joseph Gallagher. We have one of our subsidiaries. They do ventilation systems. SPA is called. So this is a ventilation, ventilation machine from SPA that I saw during my last visit. This is it's called the silent. I think they call it the silent ventilation system. Barbecue, you've probably seen this one. Obviously, it doesn't make no noise. So when you operate this onto, let's say on our HS2 jobs, you understand that makes no noise, which is in a way sustainable from the social responsibility perspective, I guess. Yes. Moving on to the next slide, digital innovation in tunneling, in sustainable tunneling. Digital technologies are taking over the world, transforming tunnel construction as well, making projects safer, more efficient, and more sustainable. Smart technologies are in the heart of this. The BIM modeling brings all project data into single coordinated models, improving decision making and reducing errors. AI is going to be big because it analyzes vast amounts of information to predict maintenance needs and optimize construction processes. Real-time monitoring sensors can track structural conditions and environmental factors, allowing for preventative maintenance that extends tunnel lifespan. You can see a nice picture, all these different AI monitors, being implemented into today's tunnelings, Automation is also going to be big. It is already. Robotic and autonomous systems are being used for precise tunneling operation, reducing need for manual labor and hazardous environment. As we said, doing things right first time. We know machines can do that. If we are doing a tunnel and we do it wrong and we have to redo it, this is twice all the emissions and all this kind of stuff. So that's very important. The benefits are clear. Resource efficiency is improving, and as tunneling evolves, embracing digital transformation is no longer optimal, is essential. We're slowly coming to an end, so just bear with me a few more slides, guys. Sustainable water management and biodiversity conservation. This is a big one. Tunneling interacts with groundwater, ecosystems, and natural habitats, making water management and biodiversity protection essential. Without proper planning, tunnels can alter water flow, lower water tables, disrupt wildlife, and cause soil instability. Sustainable design ensures minimal ecological disruptions while maintaining structural integrity and regulatory compliance. Water management is key. Closed-loop water recycling systems are increasingly used for TBM cooling, dust suppression, and grout mixing, reducing strain of freshwater resources. Control dewatering and stormwater capture further improve efficiency and prevent subsidence and erosion. Biodiversity protection is also crucial. Whenever possible, tunnels are routed away from sensible habitats. Where avoidable is not feasible, projects incorporate wildlife corridors, habitat restorations, and wilding efforts to maintain ecological balance. We talked about materials, excavated materials, and how they are being repurposed. An addition here is that they use them in coastal defenses and wetland conservations. I think you covered that as well, Michael, before. Noise and vibration mitigation further minimize disruptions to bird species and all the biodiversity. Here we can see some examples of how we manage water, sustainable water management in some of our offshore works. I think Babikir, again, you've been involved in a few of them, yeah. We can see the yellow line. You see my mouse here, the yellow line, how these systems are used efficiently to, if there is a spill or if there is some type of contamination, to contain the leak, yeah, and it doesn't get expanded onto the open waters. Now, this is the last slide. So this is, in a way, since we are in the Josh Gallagher office, okay, this is our commitment to sustainability. Okay, obviously this is some of the objectives I've got from our sustainability manager, and basically we talk about the fact that sustainability is at the heart of what we do, from tunnel design to construction and operations. By focusing on carbon reduction, energy efficiency, and waste management, responsible sourcing, we are driving, standards for sustainable tunneling. Sustainability begins at the design phase. I would say a lot of things everything begins on the design phase within construction, where we prioritize low carbon materials, energy efficient methods, and circular economy. We are exploring into science-based targets initiative to achieve a 10% reduction in energy consumption, implement smart waste globally, and conduct energy audits across the Middle East. Obviously, we have operations in the Middle East as well. To further reduce emission, we are transitioning 50% of the diesel-powered equipment to hybrid and electric alternatives. Renewable energy is a key pillar for our strategy. We are working towards sourcing 50% of our energy needs for renewables, including solarization of the Middle East offices and sites. We're also committed on 100% waste diversion from landfill, ensuring at least 80% of materials are either recycled or BES 6001 certified. Paperless office initiative further supports waste reduction across our operation. Obviously, Babikir didn't really stick to this.
Yeah.
Yeah.
We have to print some papers today
but
for
again,
Michael, that's why.
Yeah. This is again though the objectives for the next few years. Yeah, we have a few more years.
Yeah, bring iPads next time.
Yeah, we have a few more years.
Maybe printing the paper would be less energy intensive than printing the
Beside,
iPad.
Probably. To uphold sustainability standards, we conduct obviously a lot of supply chain environmental audits across all our businesses and all our subsidiaries, ensuring compliance and responsible sourcing. Education and awareness is also essential, which is why we are rolling out environmental sustainability training matrix for site personnel and hosting quarterly awareness forums. Beyond our own projects, we are actively contribute to industry leadership through collaboration with British Tunneling Society, UK Infrastructure Carbon Review, and research institutions. We are doing our best to shape the future of sustainable construction, I would say. Sustainability is the goal, is how we operate, innovate, and lead. And this is why, again, I believe what you guys do here is very important, yeah, because you're raising awareness and you're training people. This is a little bit of, probably most of it is irrelevant, but you can just see some of our sustainability, environmental awards. I would say, obviously, we got a few Green Apple Awards. I think that's how they're called. Yeah, you can see 2020, 2021, we have ISO 14001 accreditation, integrated into our IMS, and probably a few more that I wouldn't necessarily know. But as you can see, we have a Green World Apple as well. That's I didn't know that one, Babikir. But yeah, we have a lot of apples. They're somewhere in the office in the headquarters.
And after that, they keep the doctor away.
Yeah, we have the apples. They're really actually apple trophies, yeah. So we have a lot of apples, and maybe some of our memberships. Is there any related to here? So we got, we mentioned 14,000.
There's another laptop there.
So, there is a lot more. There is a lot more actually, yeah. But we can see some supply chain sustainability school. I think that's definitely a sustainability one. The green apples and probably a few more. But yeah, I think that's pretty much the end of the presentation. Thanks a lot again, everybody. Again, guys, it's been a pleasure. And also, I learned a lot of things going through this presentation. Yeah. So thank you for giving me the opportunity, and I hope I didn't bore you to death. Okay.
Thank you.
Thank you. That was really good. I guess if there's any questions from anybody, either online or in the room, a few moments to cover questions.
One. I've got one question and one statement. So I'll
Okay.
do the statement one. When you mentioned the oldest tunnels,
Yeah.
one of the oldest tunnels is called Qanats
Yeah.
that are generated in Iran.
In Iran, Persia.
700 BC.
Okay.
Just say
Okay.
that was a statement.
Okay.
That's the Iranian in me coming out.
It's actually very interesting. I've seen them.
Yeah. But the question is, the silent ventilation one was really interesting. As working on site, the ventilation machines are so loud, and you cannot operate them as much as you wish to because of how loud they are. How big is that? How much does it cover, basically?
So leave it to you.
Let me probably share my screen. Yeah, because let me find it. That is a good question, actually.
Is it like widely available, or
We have like R&D team keep developing fans because we have like part of the group called SBA. So we manufacture those fans on site.
Right.
So they always take feedbacks.
Is there any projects that it's been implemented?
Yes, on the HS2 projects we've been implementing. So it's basically, this is the
Can you share
one.
your screen?
That's, yeah, let me share my
It's called
screen.
super silence ventilation system.
Yeah,
Very
yeah.
interesting.
Let's have a look. I'm not. I might be. You know, it might look like I'm promoting SPA, guys. maybe I am. Maybe not. I guess we'll never know. But this is basically what we're referring to as the super silent ventilation fans. I cannot answer maybe a lot of technical details to it.
Yeah.
But from the conversation that I had with the guys in the yard, basically, it's just a normal ventilation fan, but they have added a lot of insulation on the outside, and they have specifically modified it to generate as less noise as possible.
Is it? I know you said you won't answer any of the technical questions, but is it massively heavier or more energy intensive to basically combat that sound? Assuming if it's heavier, it means you need to design your support on top of in the crown of your tunnel to hold a bit more weight. Or if it's more energy
A lot of
intensive.
temporary work to hold it there, but
Yeah.
we can get you the technical specification and
Yeah,
then you can
I'm
review
actually
it.
keen to
I
know.
understand. Yeah, again, I think both the questions are great, and I wish I was in a position to answer your questions, but unfortunately, I don't want to say stuff that are incorrect. So, but yes, that's all I know is that we do have them, and they're generally out in the industry. We haven't discovered the wheel yet, but yeah, they're out in the industry, and they are a great solution for environments like busy environments that if you, as you said, if you want to do works overnight and you are right next to like a big apartment and stuff like that.
It's a great idea, by the way. We can make a visit for the BTSYM members to our yard and
Yeah.
see the manufacture of the fans.
Definitely.
That would be
Call the
very
guys here.
Yeah, we can. It's a big yard. We have a lot of specialist equipment.
I'll keep you
Yeah.
accountable for that offer.
But yeah, thanks for the question. Is there any other questions maybe anyone wants to ask?
I have a question. Yeah, just when you were going through the get it right first time one.
Yep.
Are you reporting kind of rework in terms of carbon, or is it just captured through the money and the kind of volumes that we use?
It's a very good question. I think the get it right first time is a very interesting topic. Okay, so it's a very interesting topic. So why do we want to get maybe I'm gonna try to be a little bit more wide in the answer. So why do we try to do things right first time? We try to do that because first of all, client satisfaction. Okay. Client satisfaction means more work. If the client is happy, if we do what we do right the first time,
See repetition also.
we're gonna do
tied to what you're doing.
it's reputation, because if you're doing things wrong, that affects your reputation as a company, and obviously, that's not good. But also it's cost effective from a lot of perspectives. Either we're talking about money or we're talking about carbon materials. Yeah. So doing things right first time is not just an initiative, it's a mindset. It's a mindset, and it should be. I think the more we are progressing as an industry, the more you see this message around. We actually have some stickers. You finish them all?
Yeah, I'll give them all, some of them.
Okay, I gotta bring some more next time. But yeah, it's. Do you want to maybe? Did I cover you? Do you want to?
I was just wondering if you report it in terms of carbon as well. I don't know if you're reporting them. Like
He's asking about the carbon.
specific rework
yeah.
events.
Emissions.
Like, are you calculating the carbon cost of that? Do you know what I mean?
When we don't do things right the first time,
if you have to rework something.
that is a good question, and most likely I would have to say not necessarily. We don't. We could be doing that, but I don't necessarily think we are. As you know, in our industry, cost is probably work hours. Cost is what drives it. But I would say that again, after a lot of sustainability research that I've done over the last week, I think that even if we're not doing it, I'm definitely going to push for us to start capturing these aspects of the reworks and errors within our construction activities. Yeah.
Thank you.
No problem.
Oh, I
Michael, any
think
questions from you?
no questions from me. I was very impressed,
Yeah.
and no questions online, I don't think. But maybe we can start on the activity section now.
Yeah.
So I think, yeah, maybe we'll have like 20 minutes, and so come back together at about 20 past 7, and we can kind of share what we've come up with. I'll quickly present what the task is actually. If I share my screen again. Oops. It's gone. Annoyingly, I've got to click through all of them. Right. So, yeah. So hopefully everyone in the room has copies of these sheets, and then we can do it online as well. And so we've basically got this kind of fictional project in the middle. So the kind of scenario is good news. A major tech company wants to build a new data center and headquarters in the UK. And they've proposed the below footprint in red. And there's a new proposed road connecting the site to existing infrastructure. The proposed headquarters and data centers will be a combination of low and high rise structures. Your task is to annotate around the map to highlight key sustainability design options for the highlighted elements. And so you can kind of see we've got boxes around the outside. So there's a road cutting kind of going across here along this raised area. So it'll be in a bit of a cutting, or like cutting into the slope. Then there's tunnel as well. So I mean, it's an already built tunnel, but you can come up with sustainable design options for the tunnel. Road bridge crossing here. Then there's also soft ground near the river, which we need to be aware of. Building foundations, so the building here, so again, a mixture of high and low rise structure, so deep and shallow foundations. Coastal, so they've geniusly decided to put it on the coast. So there's some coastal erosion considerations, and then there's a high voltage cable coming in from an offshore wind turbine up here, and landing it, and then also I'm going to double copy that. But basically, yeah, one was the tunnel, I think, for the cables itself, and the one was the landing. So hopefully that's all clear, and we can have some discussions, and then yeah, come back in about 20 minutes. So,
Yep.
Cool. Yeah. So I'll stop